Okay, so I've asked everybody to turn in 11-2. I've already graded it and put them up. To rip out your 11-3. And 11-3 is probability of multiple events. And our objective today is to find probability of an event A and B, and to find probability of the event A or B. So the difference between these two are the verbiage, and, or. So between two different events. So for your bell work today, I ask you to pull out the study guide for this part 1 of this chapter test and work problems 5, 6, and 7. Yesterday you worked 1 through 4. And I ask you to check your work with your aisle buddy. Okay, so now you're down through, 7 was the dart one. The number got taken off with the hole punch. So that was 7, right? So if you look at the back of your study guide, at the bottom it tells you today we're doing 11-3. So that's going to be problems 8, 9, and 10, which will work tomorrow morning. And then at the end of the hour, we'll do 11 and 12. Okay? And then the next day, we'll have our test. All right, so let's continue. We're not going to have time to do this because I'm doing this in one day. Last year I split it up into 2. But it says read below and create your own set of dependent events and independent event. So let's just read the definitions and see what these mean and what they are. So our essential understanding is to find probability of 2 events occurring together. You have to decide whether one event occurring affects the other event. So does one thing affect the other thing? Or does drawing one thing out of a bag affect what we're going to draw out of the rest of the bag? Wake up. Okay, so when the occurrence of one event affects how a second event can occur, the events are dependent events. They depend on each other. Otherwise, they are independent events. So let's look at some examples. It says, is each pair of events dependent or independent? Okay, so our first problem says roll a number cube, then spin a spinner. So if I roll a dice, is it going to affect what's going to happen on the spinner? No. So they would be independent events. One does not affect the other. So roll a dice, it's going to do something, and then you're going to spin a spinner, and it's going to do what it's going to do. Rolling the dice has no effect on what happens with the spinner. Do you see that? Pick one flashcard, then another from a stack of 30 flashcards. So would that, picking the first card, have an effect on what you draw the second time? Think of a deck of cards. I've got 52 cards to pull from, and I pull one out, and I set it aside. Does that affect what I'm going to draw on the next draw out of the deck? Yeah, because it's going to be one less. Like if I pull the King of Hearts, well, now my second hand or my second draw is going to be affected because the King of Hearts is not there, right? So picking the first card does affect the possible outcome of the second card. So these events are dependent on each other. What you draw the second time depends on what you drew the first time. So if you drew the King of Hearts, you know you're not going to draw the King of Hearts a second time. So it depends, right? The second draw will be anything but the King of Hearts. So let's look at our workbook page 1 through 4. And let's look at these. Roll a number cube, then roll it again. Does the first roll affect the second roll? Yes or no? They don't affect each other, so what are they? Independent. So write independent. Or put a big I. I did IND, period. All right, number 2, pull a card from a deck of playing cards, then pull a second. Are they independent or dependent? Dependent, correct. Number 3, randomly choose a student from your class, then choose another student. Dependent, very good. Flip a coin, then spin a spinner. Independent, there you go. See how easy that homework was? Any questions? So IDDI. So here's the probability concept. Probability of A and B. If A and B are independent events, like roll a dice, spin a spinner, if they're independent, then the probability of A and B is equal to the probability of A times the probability of B. So you multiply. So I used to say this word last year, tried to remember, multipland. I made it up, like it's a multiply land. But you multiply on and for probability. Okay? And I just make up weird things like that all the time to remember stuff. And that's just something that helped me. If it helps you, fine. If it doesn't, forget it, right? So let's look at this probability of independent events. At a picnic, there are 10 diet drinks and 5 regular drinks. There are also 8 bags of fat-free chips and 12 bags of regular chips. If you grab a drink and a bag of chips without looking, what is the probability that you get a diet drink and fat-free chips? So we've got 2 things going on here. We're going to grab chips and we're going to grab a drink. Are those dependent or independent? Independent, because you got a pile of chips over here and you got drinks. So pulling a chip has no effect on pulling out a drink, right? So they're independent, and that means if they're independent, we've got 2 events, then we're going to take the probability of the first one, and whatever that is, we're going to multiply it to the probability of the second one. So let's work on the first thing. They say, my pen, grab a drink, and then grab a bag of chips. What's the probability you're going to get a diet drink and fat-free chips? So let's look at the diet drink first. We'll call that probability A, picking a diet drink. And we'll call probability B, or event B, picking fat-free chips. So they're independent, so we're going to say probability of A and B is equal to the probability of A times the probability of B. So we know we're going to get our probability, we're going to take the number of diet drinks, which was 10 diet drinks, over the total number of drinks. So there's 10 diet, 5 regular, so 10 over 15. And then number of bags times the number of bags of fat-free chips. Let's see, there are 8 bags of fat-free chips over, and then there's 12 regular, so that's 20 total. So it's going to be 10 over 15 times 8 over 20. Right? And when you multiply that out and simplify, you get 4/15, which is congruent to 0.267 or 26.7%. Okay? Any questions? So just when you have 2 independent events, multiply. So you've got about a 26% chance of just randomly reaching in there and grabbing one fat-free chip and a diet drink. Any questions on that? All right, let's look at our numbers 5, 6, 7, and 8. Go with this problem. We're not going to work them all in class. Let's look at the first one, though. Use the table shown below to answer the following questions. So number 5 says you randomly pick a video and a DVD. So here's our videos, there's our DVDs. What's the probability that you pick an action video and a comedy DVD? So action video, comedy DVD. So we have to get the total of all these, right? So when you total this, you're going to get 20. Oh wait, no, 30. 8, 10, 30, sorry. And when you total these, we're going to get 50. So there's my total. So it says, what's the chance of drawing an action? So it's going to be 12 over 30 times, and we could say P of A and B. And I probably shouldn't use an ampersand. I should probably write A and B. All right, 1230, and then 8 over 50. Okay? And that's how you set these up. When you finish, it comes out to about approximately 0.064, which is about 6%. Okay. So I know a lot of you will simplify, like you might take that down to 6/15, 4/25. 6 times 4 is 24, 15 times 25. So however you want to do your math. And some of you will just plug it in the calculator. Okay. Any questions about how to work these? So at home tonight, you'll work 6, 7, and 8 is an independent writing. I do want you to do that as well. Explain the difference between independent events and dependent events. Actually, why don't you take 1 minute now and do that? Explain the difference between independent and dependent events. So answer number 8 at the bottom of your page now. Okay, you've got 1 minute. And if you finish, go back and work 6 and 7. Ten seconds. Okay, so wrap up what you're doing. If you didn't finish, then just do it at home tonight. Or if we have time left over, you do it then. Let's look at mutually exclusive events. Now, what happens when they're mutually exclusive? Two events that cannot happen at the same time are mutually exclusive events. So let's look. Cannot happen at the same time. If A and B are mutually exclusive events, then P of A and B equals 0. So there's no probability that they can happen at the same time. That's mutually exclusive. So let's look at some examples. You roll a standard number cube. All events are the events mutually exclusive, and explain. So think about a standard number cube is just a dice. So is it mutually exclusive? Rolling a 2 and a 3. Can you roll a 2 and a 3 at the same time on one die? Yes or no? No. So that means the events are mutually exclusive. Right? You can't do it. When you can't do this together, it's mutually exclusive. How about rolling an even number and a multiple of 3? Is that possible by rolling one die? An even number and a multiple of 3. Well, what multiples of 3? You know, we have 1, 2, 3, 4, 5, 6. Those are the numbers we can roll on a die. What's a multiple of 3? A 3 and a 6 are multiples of 3. So can one of these also be an even number? Which one? So this is possible, right? So they are not mutually exclusive. Okay, not mutually exclusive because it can happen. You can roll a 6, which is an even number and a multiple of 3 at the same time. Okay? Let's look at our workbook, 9, 10, 11. So, 2 fair number cubes are rolled. That's like 2 dice. State whether the following events are mutually exclusive. The sum is odd and the sum is less than 5. Can you have that? You're rolling 5 of them. Okay, so the sum is 5, so that means that you could roll a 3 and a 2, or a 2 and a 3. So there's a sum is 5. Now it says the sum is odd and the sum is, less than 5. Excuse me. So what do you think? Is it not mutually exclusive? Is this a possibility? So if we roll a sum less than 5, that means it's got to have a sum of 4, 3, 2, 1, right? Actually, let me go to your homework page. There we go. 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6. Okay, so we want to roll a sum less than 5. So it's got to be 4. 4, 3, 2, and rolling a 1 is not possible. So it's got to be a sum of 4, 3, or 2. But it's got to be the sum being odd. So that knocks these out. So can I roll 2 dice and get a 3? What would it be? A 1 and a 2, or a 2 and a 1, right? So it's a possibility. So it's not mutually exclusive because it's a possibility. You could roll a 2 plus 1 or a 1 plus 2. The difference is 1 and the sum is even. Is that a possibility? So if we add the sum of 2 dice, it's got to be even. But the difference is 1. So that means if I start off with a 2 and take away 1, if I take an even number, that means I'm going to be adding to it an odd number. Always, right? You're going to have an even and an odd. What is an even and an odd equal? Is it going to be always equal to an even number or an odd number? It's always going to be an odd number. So this is not a possibility. So that means these are mutually exclusive. It's never going to happen. You can't. Now if they said difference of 2 and the sum is even, or difference of 1 and the sum is odd, then it would be not mutually exclusive. But this is not a possibility. You can't have a difference of 1 in these 2 dice, and that when you add them together you get an even number. It's not possible. Okay, in 11, the sum is a multiple of 4 and the sum is odd. So a multiple of 4, when we add these, again, we're going to have 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. So the sum is a multiple of 4. That means 4, 8, 12. So what can I add and get a 4? I could get a 3 and a 1. If the sum is a multiple of 4 and the sum is also odd, is that possibility? What is 4? Is it even or odd? So can it be both even and odd? No. So it's mutually exclusive. It's not possible. Okay, so you could go through all the ways of figuring out what it is, but really it's better just to step back and look at the big picture of, that's an even number. 4 is even. Can you take an even number and make it odd? No, you cannot. So it's just not even possible. So really we didn't even have to look at numbers to figure that one out. Say again.
The sum is a multiple of 4.
Mm-hmm.
Oh, this is the sum.
Yeah, the sum. So it means you're adding. We're not multiplying. So multiple of 4 means the sum had to add up to be 4, 8, or 12. But if your sum is 4, a multiple of 4, it means it's always going to be even, even, even. Can that sum also be odd? No. It's going to be even or odd. It can't be both. Okay? But I can see how it's easy to twist the words around and think, oh, I'm going to multiply. Nope. All right, any questions on those? Doing a good time. All right, let's look. Now we talked about the and. Now we're going to talk about the or, probability or, like this or that, not this and that. Now we're talking about or. So when we talk about or, we got to do a little more work. It says the probability of either event, event A or event B occurring, you need to determine whether events A and B are mutually exclusive. Excuse me. Just say it. Okay, so when you have probability of A or B, you're going to have probability of A plus the probability of B, and you're going to subtract the things that are both A and B. And I know in words this is sort of hard to visualize. We'll look at an example. Okay? So it says, at your high school, a student can take one foreign language with each term. About 37% of the students take Spanish. About 15% of the students take French. What is the probability that a student chosen at random is taking Spanish or French? Well, they're not talking about 100% of the school here, right? They're talking about 37 and 15 out of the whole student body. So you could say 37 over 100 take Spanish, and 15 over 100 take French, right? So let's use that rule. So we know we're going to take the Spanish plus the French, and then we're going to do that first. And they are mutually exclusive because they can either do one or the other. They can't do them together. So they went ahead and put them in decimal form. 37 over 100 is 0.37, and 15 over 100 is 0.15. So we're going to add those together, and it's 0.52. Okay? And there's none that take both together, so you don't have the subtraction part of it. So you're just going to add them. So you have a 0.52 or 52% probability that when you choose a student at random, they're going to be taking either Spanish or French. Okay? So you just add them. So, and then we'll talk about when it gets a little more complicated in a minute. Right now they can either do Spanish or French. There's not a likelihood that they're taking them at the same time, right? They're mutually exclusive, so you're just going to add them. So let's look at number 12 in your workbook. It says students can either participate in a track and field or play baseball. 13% of the students participate in track and field, so 13%. And about 8% play baseball. What's the probability that a student chosen at random either participates in track and field or plays baseball? There's that or, so we're going to add it. All right, so we are going to have 13 over 100 plus 8 over 100. And notice that our fractions are the same, so you could actually just add 13 plus 8, which is 21, over 100, which is 21%. Okay? See how easy that is? I will leave 13 for you to do at home. Okay? And you'll work them just like that. Any questions over that? Yeah, because you're talking about population. Well, look at this. You've got 1/5 of the population. So here I would go ahead and turn that into a decimal. What is 1/5? 0.2. And then what is 2/7? 2 divided by 7 is 0.285. 0.285. Let's go ahead and round that up. That would be about a 2.9. All right. So when you add 0.2 plus 0.29, what do you get? 0.2 plus 0.29. You get what? 0.49. Which is how many percent? 49%. Well, that one's already done, right? So is it always going to be over 100? You could say that that's 20 over 100 if you're trying to get that to 100%. But we're talking about populations, and you're going to have 100% of the population is your total. So in that respect, you will always have 100, okay? But sometimes it's represented as a fraction, okay? So this is as hard as these are going to get. And if you look at your problem, let's see, that's problem 3. Actually, this isn't even on the test. You got 2, 4, and 5 on the test. So this one's not even on the test. Oh, wait, yes, it is. It is on the test. 4. So 4 is number 9. So number 9 is like this. Suppose S and T are mutually exclusive. Find P of S or T. So they give you 36% and 20%. Right. So what are you going to do with those? Add them. So, okay, I've got to do the last problem. And I really don't want you doing the study guide till after you do the homework, though, because I want the study guide to be done without help. You should learn on your homework and then be able to get the study guide and just work it. Okay. Maybe glancing at notes. Okay, now this is the hardest that it's going to get, and this is actually pretty easy, so I think we're doing good. When two events are not mutually exclusive, that means that, you know, we said it could be Spanish or French, but not both. Well, what happens if some of those can intermingle and they can take both Spanish and French? So what you have to do is take out, you know, if you add all the Spanish plus all the French, some are going to be double counted, right? Because they're in both. So you have to take out the ones that are in both Spanish and French. So let's take a look at how you work those. You're going to take the Spanish plus the French, and then you're going to take away the Spanish plus the French. Okay, to account for those that got double counted, right? So if I had 5 kids here, and one of these are in both Spanish and French, and I've got 6, let's go 10 over here. Well, that means he got double counted because he's in both. He's counted twice. So you have to take away that one student that's in both Spanish and French. So that's the only difference in this. So let's look at how we use those. Suppose you reach into a dish and select a token at random. What's the probability that the token is round or green? So we have to look round or green. So those are the two things we're dealing with. We have to look at the total number we have first. So let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have 9 total. Now let's deal with the round ones. How many of these 9 are round? So we're going to go 1, 2, 3, 4, 5. I have 5 round. Now I'm going to add to that the green. So round or green. So how many green do we have? 1, 2, 3. Now, some of these got double counted. So we have to take away the ones that are both round and green. So let's look. Round and green, I've got 1, 2. So I have to take away 2 9ths. You see that? Now that gives me a proper number. Notice that my denominator is all the same, so I don't have any conversions. All I have to do is go 5 plus 3, which is 8. 8 minus 2 is 6. So my final answer is 6/9, which should be C. All right, and that's correct. Any questions over that? That's everything, guys. Let's look at your homework and do this last one. 14 says, suppose you randomly select a shape from this circle. What is the probability that the shape is black or has 5 points? Okay, so we're working with how many shapes? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10. So now we need to get the black shapes. 1, 2, 3, 4, 5, 6. And how many have 5 points? 1, 2, 3, 4 of these. Okay, now how many of those are black and 5 points? So 1, 2, 3. So since those got double counted, we have to take them away. There you go. So now our answer is going to be what? 6 plus 4 minus 3, which is 7. So 7/10 is our answer. Or you might want to write that as 70%. About 70%. Are black or have 5 points. Okay, now work number 15 on your own, and you already know that there's 10 shapes.
How is 7 minus 3 7? Is 4?
It's 6 plus 4, that's 10. 6 plus 4 is 10, and 10 minus 3 is 7. See, 6. Oh, I keep erasing. You see that? 6 plus 4, which is 10, and 10 minus 3 is 7. Do you see that? All right, now work number 15. And then your homework, you basically have like 3 minutes of homework. Yes. Okay, let's look at. Okay, so you've got to do it this way. We're looking at shapes that are black or 5 points. So the first thing we have to do is get the total number. How many total were here? 10. So we know it's going to be 10, 10, minus 10. So first you have to get all the black objects. How many black objects do we have? 1, 2, 3, 4, 5, 6. Okay, now how many of all these objects have 5 points? 1, 2, 3, 4. Now we have to take away the ones that are both black with 5 points. So that would be 1, 2, 3, because they got double counted. Because they got counted twice, so you have to take away the ones that are both black and. Because see, these 3 stars got counted here, and they also got counted there. So you have to take away the ones that are both double. So take away those 3, and then you're going to have 6 plus 4 minus 3, which is 7/10. What I would do, I'm doing it both ways because you never know what the test is going to have. Is the test going to have it as a percentage, or is it going to have it as a fraction? So I try to show it all ways. So I would say go ahead and simplify for homework's sake, but realize on the test it may not be simplified. So I always say look at your choices before you start. So I would look, is my answer 7/10? Oh, it's in percentages. Okay, it's a 70%. Okay? I am still recording, but I'm still getting questions. So I try to record all the questions. Thank you. We'll turn this in tomorrow and work the last of our assignment. This concludes our lesson.